Hello everyone, welcome back to Sowkya Division. Today we are going to discuss the changes during muscular contraction. In the last class we have completed the properties of skeletal muscle. Today we are going to see the changes during muscular contraction. So what are the changes that occur in the muscle during muscular contraction? There will be excitation, contraction, coupling, role of troponin and tropomyosin and sliding mechanism. This third point is very important. Yes, so these muscle contraction are divided into three main headings: excitation, contraction, coupling, role of troponin and tropomyosin, sliding mechanism. Yes, let's see one by one. We are going to start with excitation, contraction, coupling. What is it? See, whenever a muscle fiber is stimulated, any impulse reach to muscle fiber, there will be excitation of the muscle fiber. Yes, whenever the stimulus is stimulus given to a muscle fiber, that shows excitability. Yes, that leads to generation of action potential. Obviously we know that, right? In the last class we have discussed that whenever the stimulus is given, the muscle fiber show action potential. So the spread of action potential is done through T tubules, that are transverse tubules that are containing cisternae. Yes, whenever the action potential is generated, that generated action potential is spreaded via transverse tubule and reaching cisternae. The cisternae containing what? Calcium. Yes, the cisternae containing calcium. So the calcium from the cisternae are released. Yes, whenever the action potential is given, whenever the action potential is generated, the action potential reaching the cisternae, causing release of calcium from it. So the calcium that are released from the cisternae are transferred, they are traveled towards the actin filaments. Yes, that leads to contraction of the muscle fiber. This is the excitation and the contraction coupling method. Yes, the excitation, the muscle got excited, in the final it got contracted. So the impulse, whenever the impulse is given to a muscle fiber, that leads to excitation of muscle fibers, that leads to generation of action potential. When the action potential reaches to the transverse tubules and reaches the cisternae, that cisternae containing calcium are released, that calcium are travel towards the actin filaments, that leads to contraction of the muscle fibers. Yes, that leads to contraction of the muscle fibers. Now let's see what is the role of troponin and the tropomyosin. This is the troponin, tropomyosin are the proteins of actin only. Yes, actin only. These are the part of actin filaments only. Yes, so whenever the muscle fiber is in relaxed state, whenever the muscle fiber is in relaxed state, what happens? Normally the F actin is containing a active site. Yes, it containing active site, it is covered by tropomyosin. Yes, the active site of the F actin is covered by the tropomyosin. Why? So that the myosin head cannot be bind to the active site of F actin. Normally during contraction, the head of myosin get attached to the F actin, active site of the F actin. So in the relaxed period, the tropomyosin covers the active site of F actin. So there will be no binding between myosin head and the active site of the F actin. So the calcium that bind to troponin, we have seen that, no, the calcium is released from the cisternae, that is come towards the actin filament. So here the calcium bind to the troponin C, that pulls tropomyosin away from the F actin. So the tropomyosin is covering the active site of F actin, right? So whenever the calcium that binds to the troponin C, that pulls tropomyosin away from the active site of F actin. So that what happens? There will be exposure, the exposure of active site of F actin. Whenever there is exposure of active site of F actin, there will be binding of head of myosin to the actin filament. Yes, to the F actin. In the relaxed period, the active site of F actin is covered by tropomyosin. Whenever the calcium is released, it binds to the troponin C, that pulls the tropomyosin away from the active site of the F actin. That leads to exposure of the active site of F actin. Then the head of myosin get attached to the active site of F actin. Yes, this is the role of troponin and the tropomyosin. Now let's see the sliding mechanism. Yes, the sliding mechanism of the muscular contraction. See, as I said, there will be large amount of release of calcium from the cisternae. Cisternae are present in the transverse tubule. So there will be release of calcium ions. The calcium ions, whenever it is released, it get binded to the troponin. As I said, it get binded to the troponin C. There will be changes in the position of the troponin. Whenever the calcium bind to the troponin, there will be some changes in the troponin position. So that pulls a tropomyosin away from the F-actin. As I said, the F-actin is covered by tropomyosin. Whenever there will be calcium bind to the troponin C, that pulls the tropomyosin away from the F-actin. There will be exposure of F-actin. Whenever the tropomyosin is removed, there exposes the F-actin. Now the myosin head and the F-actin are binded together. The myosin head get attached at the F-actin. That myosin drags the actin filament. That whenever this is a myosin head, this is a myosin head. Let's say this is the F-actin. This myosin head get attached here. Yes, attached here, and this drags towards it. This drags and drags the actin filament. That is known as power stroke. Yes, so after completion of this dragging movement, the myosin get detached from the F-actin and return to its original position. Yes, after dragging, it reaches to its original position and detaches from the F-actin. So myosin head again, after completion of first movement, it bind with the new F-actin, new active site of F-actin. So again, active myosin complex is formed. That is known as contraction. Yes, that is known as contraction. Whenever the calcium is released from the cisternae, that go and bind to the troponin C, which pulls the tropomyosin away from the F-actin, active site of the F-actin. That leads to exposure of the F-actin. So myosin get attached to the active site of F-actin, bind with the active site of F-actin. That drags the actin filament. Yes, that drags the active filament. That is known as power stroke. Now after completion of this, the myosin again go back to its original position. Yes, return back to its original position. Once again, the myosin head get attached to the F-actin, again sliding and again going back to the original position. That process is known as sliding movement. Yes, once it is getting attached and detached, attached, dragging and detached, attached, dragging and the detached. So that process is known as sliding mechanism. Once again, it is going to form a complex, actomyosin complex, and leading to contraction of the muscle. Yes, this is the muscular changes during the muscular contraction. If you have any doubt, please comment in the comment section. Like the video, share video with your friends. Please subscribe the channel. Thank you.